morning, students. Today we are going to discuss regarding the next topic in solid state physics, that is Miller indices. Okay. In the last class we discussed regarding the what Bravey lattices. We know that the lattices can be arranged. The points, the regular arrangement of points in the space can be arranged in how many ways? Can be arranged in how many ways? 14 ways. Already we saw in the last class. Today we are discussing regarding the Miller indices. Before going to Miller indices, see, if you take some lattice points in the space, okay, right? Lattice points in the space, these lattice points, in these lattice points, we can make so many planes, okay? There are different kinds of planes, okay, by using these lattice points. See, the lattice points, already we know what are lattice points. They have regular element of points in the three-dimensional space. Now, the question is what? Actually, these lattice points, by joining the lattice points in the space, okay, we can form many planes in the lattice, space lattice, okay. By using these points, see here, this is the one type of the planes. We join the some lattice points, and these are the other type of planes, okay, A, B, and if we join the points like this, okay, this is the other plane, like that. See, there are so many planes in the space lattice. We can arrange so many planes in the space lattice by using the lattice points, by joining the lattice points in different ways. Okay. Now the problem is that how can we designate these planes in the crystal system? See, if you take any crystal, there are regular element of points or atoms in the crystal system. Now, if you take any crystal system, right, the plane, for example, if I take one unit cell, it is better to understand. Let us consider a unit cell. So these are the, I took one simple cubic lattice unit cell, simple cubic unit cell. Okay, here, see, these are the points in the three-dimensional space. This is a coordinate system, x-axis, y-axis, and z-axis. Now, there are so many points. Let us consider there are 4 points. Okay, these points I join like this. I make one plane by joining the 4 points of the unit cell. I got one plane, isn't it? I got one plane. This plane is intersecting on y-axis. That plane is intersecting on y-axis, isn't it? This is the y-axis. The plane is intersecting the y-axis, not x-axis or z-axis. Now, again, I can take other plane which is intersecting only on x-axis. Okay, like that, I can form many planes by using the lattice points in the space. Now the question is, how can we designate these planes in the crystal system? Okay, that can be, how can we represent this plane? For example, if you take a coordinate system, x-axis and y-axis, if you take any two-dimensional coordinate system, if I took any point in the space, okay, in two-dimensional, how can we represent this point? By using x comma y. Okay, now this point, for example, if you take, it is 2 units far from the y-axis and 3 units far from the x-axis, then this point can be represented by 3 comma, isn't it? So, with respect to coordinate system, this point can be expressed with the coordinates of x and y-axis like 3 comma. Similarly, in the space lattice, there are so many points. By joining those points, we are getting the plane. Now, with respect to coordinate system, how can we represent this plane? That is the question. So, according to Miller find the solution for this. He designated the, or he given some integers, Okay, similar to that of the coordinate system like x comma y comma z to represent a point in a three-dimensional space or two-dimensional space. Similar to that, Miller given the three smallest integers named as HTAL. These are the three smallest integers to give the representation of the plane in the three-dimensional space. Okay, so how can we designate this plane in the coordinate system? By using the smallest integers. How can we get the Miller indices? See, simple. Here, this plane is intersecting on y-axis. Okay, nothing but what? Its intersect, the intersects of this plane are what? What we can say? The y-intercept. Let us consider from origin. The plane is intersecting at the point 1 unit from the y-axis. And what about x and y coordinates? The x and y coordinates, the plane is not intersecting at x coordinate or y coordinate. This plane is not intersecting on x coordinate or y coordinate. Where it will intersect? At infinity. At infinity. So the intercepts of this plane are what? Along x-axis it is infinity. Along y-axis it is 1. Along z-axis it is again infinity. This plane is intersecting y coordinate at 1 unit and infinity of at x coordinate and infinity at z coordinate. So infinity 1 infinity are the intercepts of what? This plane. Now what are Miller indices? Simply they are three smallest possible integers. Miller indices are three smallest possible integers whose ratios are similar to that of the intercepts made by the reciprocals of the intercepts made by the plane in the coordinate system. Simple. The Miller indices are the three smallest possible integers whose ratios are similar to that of the reciprocals of intercepts made by the plane in the coordinate system. First of all, intercepts, nothing but what here? Intercepts are what? Infinity, 1, infinity. Reciprocals of intercepts, the ratios of reciprocals of the intercepts. Reciprocals nothing but what? 1 by infinity, 1 by 1, 1 by infinity. The plane. What are Miller indices definition? The Miller indices are three smallest possible integers whose ratios are similar to that of the reciprocals of intercepts. First of all, what are the intercepts here? Infinity, 1 infinity. Reciprocals of infinity, reciprocals of the intercepts. So 1 by infinity, 1 by 1, 1 by 1. What is 1 by infinity? 0, 1, 0. So the Miller indices of this plane is how much? 0, 1, 0. How can we represent this plane now? 0, 1, 0. Simple. These are the HKs. Okay. Now I make simple for you. See, Miller indices. How can we find Miller indices? See, plane. The lattice points. What are the lattice points? We can join in our own way. Now I created one plane here in the crystal system. Now this plane having intercepts what? Infinity, 1, infinity. Now according to definition of Miller indices, what are Miller indices? They are reciprocals of the intercepts. They are the reciprocals of the intercepts, not intercepts. Reciprocals of the intercepts. So 1 by infinity, 1 by 1, 1 by infinity. Nothing but what? 0, 1, 0. If we take other example of to find the Miller indices. Okay. Let us consider other example. Okay. Let us consider other example. See, I am taking other intercept here. X-axis, y-axis, z-axis. Now I am taking this plane. Only this plane. Okay. This plane is making an intersect on x-axis at 1 unit distance. Now, what about this plane about y-axis? At infinity, it will make the intersect. See, two parallel lines can be intersect only at infinity. Similarly, the parallel planes can also intersect at infinity. So, this plane is intersecting y-axis at infinity. So, x-axis at 1, y-axis infinity, and z-axis at infinity. Now, what are Miller indices? They are reciprocals of the intercept made by the plane on the coordinate axis. Now, these are the intersects. Now, reciprocals will be 1 by 1, 1 by infinity, 1 by infinity. So, 1, 0, 0. This plane can be represented by 1, 0, 0. These are the HKLs, smallest possible integers. Okay? Simple. See, Miller indices are nothing but what? They are similar to that of the parameters, similar to that of the coordinates axis, x comma y. How can we represent a point in a coordinate system? X, y, z. Similarly, the planes in the space lattice can be represented by the Miller indices, represented by HKL. What are HKLs? Actually, what are Miller indices? They are smallest possible integers, the smallest possible integers, whose ratios are similar to that of the reciprocals of the intercepts made by the plane in the crystal system, in the coordinate system. Okay. So these are the Miller indices. Similarly, if we take some examples again, let us consider another example. See, if I take this plane, see the intercepts of this plane are what? Here on x-axis it is intersecting, on y-axis it is intersecting, and on z-axis also this plane. Okay, so 1, 1, 1. These are the intersections. Now the reciprocals of intercept 1 by 1, 1 by 1, and 1 by 1. That is again 1, 1, 1. So these are the Miller indices of this plane in the crystal system. Like that, you can take many examples. Okay, so these are the Miller indices. Miller indices are nothing but what? They are only the reciprocals of the intercepts made by the coordinate, made by the plane in the coordinate system. Okay, in the next class we will see the X-ray diffraction and also Bragg's law. Okay, Bragg's law. Okay, right. Thank you.